So I decided to create a follow-up video, one that I should have done in the previous video when we started looking at some of the Tanzu CLI commands and some kubectl commands as well, so that we could get an idea what was happening under the hood when we create class claims, when we create workloads and deliverables and so forth. At the end of the day, we're just running pods for our workloads. What I wanted to do also was show us the inside of our Postgres pod. We can go ahead and exec into that pod and run SQL commands against it and see our data. So let's go ahead and first just confirm that we're in our AKS cluster, which we are. Now, the next thing that we have to do is we have to go find our class claim that we created for our Postgres database that contains the secret or a reference to the secret, so that we can get the password and connect to that database. So even though we exec into the pod, we'll still need to log into that database with a password. So in order to do that, I'll query the Tanzu services class claim list, and there we have our WeatherDB class claim. Now, incidentally, I could just go ahead and do this as well. This is just a Kubernetes custom resource definition, a class claim that we've created that can be run on Kubernetes. So just like a normal primitive of Kubernetes or construct, like a pod or a service or a secret or a persistent volume, whatever it is, we can write our own Kubernetes resources that inherits all of the functionality that the native constructs do. All right, so what I'll do is open this WeatherDB class claim. And what we get here is our secret. This is our secret right here. Now, it's not immediately obvious. I understand that, but I just happen to know that this is the secret, which is under the claimed resource. Okay, so this is a class claim whose sole job really is to be the intermediary between our application and the connection details that we need within a secret. And so the claim is an abstraction layer that our application can use. And then the claim has a reference to the secret. So that's exactly what we're seeing here. So this is our secret. If we go ahead and query or get the secrets in our namespace, okay, this is the secret, 333. So what I need to do in that case is open this. So we'll go ahead and open this secret here with the YAML details. And so here are our connection details. These values are the values that we saw in our code. They're being injected into our pod and container. What we need to do is go ahead and grab the password, which is encoded right now at the moment. And what I'm going to do is cheat here, because I never remember the encode and decode commands that are available in Kubernetes. So you can see I use this often. And we'll decode that. And this is the actual password value. All right, so I'm going to save that off for the time being. And now back to our script. We now need to go and look for the Postgres pod. Now, if I were to just do a get pods in the default namespace, I'll see the tap.NET weather data, but this is the API. These are the pods that contain our API, not the database. So it just so turns out that the database is put in its own namespace of the same name with some random characters. So all we have to do then is list the pods that are in this namespace, and we'll have our pod right here. This is the pod running our database. Okay, so let's get that pod, or let's exec into that pod. So we're in the pod now, hosting our database. Now, what we need to do next is we're going to run some psql commands here so that we can get to our table. So I'll run now. When we install Postgres, it automatically installs the CLI as well. Our default user is Postgres, and then it's going to prompt us for the password. And now we get a Postgres prompt. So what we can do, we can run a few commands here. Every command is usually prefaced by a backward slash. We can list, that's an L right there, not a 1. We can list our databases here. So we've got our weather DB class claim right here, Postgres. So the next thing we can do is connect to it. Let's go ahead and query the tables within this database, and you'll see that we have a favorites table. Now we're at the point where we can query this table with just regular SQL syntax. Select all from favorites, and don't forget the semicolon. Now it's saying here, okay, favorites, relation favorites does not exist. Oh, it's case sensitive here, so I have to select, okay, relation favorites does not exist. Select all from favorites. What is the problem here? Okay, I went and Googled this, and it turns out that I need to add quotes and spell it exactly the way it's spelled here with a capital F. And don't forget the semicolon. And there you go. So we have our list of zip codes. So we've got 4 zip codes. The last one is 10002. And we've got 4 zip codes in our favorite locations, 10002. Let's go ahead and add another one here, and I'll do 10003. I don't know if this exists, but okay, I guess it does. So that's probably another New York zip code. It went into recent locations. Remember, this is our cache, our Redis cache, but if I hit add to favorites, now we've got 5 zip codes. Let's go back to the pod. We'll run that again. And now we've got 5 zip codes with our 03. So that's very useful, right? Because if we're troubleshooting an issue, for example, we can't figure out why we're not getting the results we expect, or we're not sure why a record isn't being inserted, whatever, we can at least come into here and do some regular SQL and determine perhaps something is wrong with the table itself. And then we can compare what we see in the database with the web application. So I hope this was helpful for you, and we'll see you in the next video.